Today we're going to be talking about another example of method of moments estimation. This is the outline that has been presented for us for method of moments estimation. We're going to go through this new example here and use this outline to find the method of moments estimator of the unknown parameter sigma, where our observations x1 through xm are from a normal distribution with parameters of known mean equal to 0 and unknown sigma. So again, we know the mean, we do not know sigma. Okay. Now, I'm going to just make my life easier. This is x1 through xn. And let's go through this process. Now, if we did the method of moments and we started with the first moment, that's not going to be useful, and let me show you why. So here, e of x is a normal distribution with mean 0, and this is going to be set equal to the average. The average is calculated from the data. The expected value of x is equal to 0. All this is going to say is that your sample average is 0. This is not useful. It does not involve our unknown parameter. Sigma. So instead we need a moment that involves the unknown parameter sigma. So I'm going to try e of x squared. This is going to be equal to the summation of xi squared over n from I equals 1 to n. Now you might ask, what is e of x squared? So we need to figure that out. Okay. We could do it directly from the distribution because we know it's a normal distribution. So here are two ways to calculate e of x squared. So here's the first way. You can just use the definition. E of x squared is this integral from minus infinity to infinity of x squared times the normal distribution. The normal distribution is 1 over root 2 pi 2 pi times sigma times e to the minus x squared over 2 sigma squared dx. So, that's not the nicest thing to calculate. It can be done, but here's another way. The variance of a normal distribution, that is sigma squared, and that's calculated as e of x squared minus the mean squared. Oh, well, the mean here is 0. So this just says e of x squared is equal to sigma. And there we go. We could use the theoretical properties. So methods of moments, we come back here and we use this little fact. This is going to say e of x squared is sigma squared, and that is equal to the summation from I equals 1 to n of xi squared over n. Now, if you want an estimator for sigma and not sigma squared, all you have to do is take the square root. Okay, so this is the method of moments estimator for the variance when the mean is 0. I just want to caution you, this does not work if the mean is not 0, so this is particular to this specific example with with this mean. Okay. Thank you very much.